Okay, Bismillahirrahmanirrahim. Wassalatu wassalamu ala Rasulillah. So we will solve recitation problem for chapter 9. So the first problem reads, in this figure below, we see 3 uniform fin rods, and I give you the length of each rod. Capital L is 22 centimeters. They form an inverted U, like a table. The vertical rod have a mass of 14 grams, and the horizontal rod has a mass of 42 grams. The question is, what are the x coordinate and the y coordinate of the system center of mass? So the system is this table here. Okay. So the system, which is my table, is made of the left leg plus the top plus the right leg. The left leg, I'll call it 1. The top, I'll call it 2. The right leg, I'll call it 3. So this is 1. This is 2. And this is 3. So what is the x coordinate of the center of mass and what is the y coordinate of the center of mass? You know that the x coordinate of the center of mass is m1x1 plus m2x2 plus m3x3, because here I have this geometry. I cut it down into 3 simple geometries, the left leg, the top, and the right leg, divided by the total mass. Okay, the total mass is m1 plus m2 and m3. And the y component of the center of mass, I have the same, m1 y1 plus m2 y2 plus m3 y3 divided by total mass, m1 plus m2 plus m3. Now, of course, x1 and y1 are the center of mass of the left leg. So here, look at here. This is my left leg, the center of mass. It's a uniform leg. It's a uniform fin rod. So the center of mass is right in the middle. Okay. So the center of mass 1 is right in the middle. And x1, if this is my x-axis and this is my y-axis, x1 is equal to 0 and y1 is equal to minus half L. Do you agree with me? Yes. And that's, this is the center of mass of the left leg. The center of mass of the right leg, I call it 3. It has 2 components, x3 and y3. x3 is, of course, L, and y3 is equal to minus L divided by 2. Do you agree with me? Okay. And the center of mass of the top part of my table has 2 components, x2 and y2. Of course, x2 is equal to L over 2, and y2 is equal to 0. Okay. So whenever you have a complex geometry, you cut it into simple geometry and you locate the center of mass of each of these simple geometries, and then you apply these formulas, this one and this one. Now the center of mass, x component of the center of mass of the system will be m1. m1 is equal to 14. Okay. By the way, I will say just m1 is equal to m3 is equal to 14 grams. And m2 is equal to what? 42, which is 3 times m. M being m1 and m2, basically 14. So I will say m1, m, x1, x1 is 0, plus m2, which is 3 times m, multiplied by x2, x2 is L over 2, plus m3, which is m multiplied by x3, x3 which is L, divided by total mass. Total mass is m1, m, m2 is 3m, plus M3, which is M. And you do the calculation, okay? And you replace, of course, the M will simplify, okay? If you want, you can put the numbers if you want, okay? 14 and 42, okay? And then you get your answer. And you do the same for Y of system, Y of the center of mass of the system. It will be M, Y1. Y1 is just minus M divided by 2. Plus M2, which is 3M, Y2. Y2 is 0. Plus M3, which is M, Y3, which is minus L divided by 2, divided by total mass, which is 5M. Okay, the M will simplify and then you will get your answer. Okay, again, you're not obliged to put M and 3M here. You can just put the numbers. If you are comfortable with them, you go for it. So this is what was done here. As you can see in the solution that I have posted, this is what was done here. And you get X of the center of mass and Y of the center of mass. Okay. Even without calculation, I could have guessed that the center of mass will be right here in the middle. Okay. Because this is an axis of symmetry. And it will be closer to the top leg because the top table is heavier. Okay. That's why this is Y equal to 0. It's roughly somewhere here at L minus L divided by 5. Okay. So the center of mass of the whole system is here. Okay, good. Now let's solve the second problem. The second problem looks the same, but here I have a plate. So the question is, find X and Y coordinate of the center of mass for this uniform plate if L is equal to 5 centimeters. It's a uniform plate. Okay. That means the density of the plate is constant everywhere. Whether I'm here, so this part here, I will call it part 1. So I have a complex geometry, so I can break it down into simple geometries. Okay, this part here, I will call it part 2. This part here, I call it part 3 if you want. And this part here, I will call it part 4. Okay, you can break it into 3 parts if you want. Okay, here I choose to break it into 4 parts. This is one start with here. Okay, and then this one. So this is 1 here. This is 2. Of course, this is 3. And finally, this is 4, part 4. Okay, it's a uniform plate. So each of these parts, of course, the center of mass is right in the middle. So let's do that. I will choose another ink. So this part 1, where is the center of mass? It's right in the middle. I will call the center of mass 1 of this part 1 here. Okay, it's right in the middle. Now, can you give me the coordinates of the center of mass x1 and y1? So if this is 3, this is what? L. So that means this is 2L. So x1 will, well, x1 is easy because x1, this is 0 because actually this is my origin. This is the x-axis and this is the y-axis. So my 0 is here. So here x1 is equal to plus 2L and y1 it will be equal to what? This is 2L and half L. So plus 2.5L. Okay. Now part 2, where is the center of mass of part 2? It's right here in the middle, as you can see. Okay. So I'll say, what is the center of mass of part 2? And of course, I'll put the x2 and y2. So x2, if this is minus L, so x2 is just minus, this is minus 2L, so x2 is minus 1L. And y2, of course, this is free, so it's half free, so plus 1.5L. Okay. Now for the part free, the center of mass is right in the middle. So what is the center of mass of free? The components, it will be x free and y free. Of course, x free will be minus L, if you agree with me. This is minus 2L, so here it's half minus L. And y free will be minus 2L. This is minus 4L, so it's in the middle, minus 2L. And finally, for part number 4, the center of mass is right in the middle. Why in the middle? Because it's a uniform plate. So the center of mass of part 4 will be at x4, y4. Of course, x4, if this is 2L, so this will be just L plus L. And y4, what is y4? So here you will have minus 2L minus L, so basically minus 3L. Okay. Now, since the density is constant and it's a plate, so that means each plate will have the same density. It will be M divided by V. Okay? So M will be just the constant density multiplied by V. But V is equal to what? V of a plate is an area multiplied by the thickness. And all these plates will have the same thickness actually. So I will have rho H multiplied by the area. So if I have my formulas, I will have, okay, let me write it this way. System is equal to part 1 plus part 2 plus part 3 plus part 4. So center of mass of the system, X of the center of mass of the system will be M1, position of center of mass of part 1, plus M2 x2 plus M3 x3 plus M4 x4 divided by total mass, which is M1 plus M2 plus M3 plus M4. Okay. Now, since each M here, I will have a common factor, rho H. Rho is constant, the thickness of each plate is constant. So you see here, of course, the rho H will simplify. If you remember, I said this in class. So here, I will have here rho H on the numerator, but in the denominator also I will have rho H. So they will simplify. Okay? So I will end up with area 1 x1 plus area 2 x2 plus area 3 x3 plus area 4 x4 divided by total area. Okay. And this just because of this fact. I will have Mi, which is just rho H Ai. Okay. So this rho H is a common factor. It will be on the numerator of each mass and it will be at the denominator. So I will simplify it. So now the areas are simple. What is the area of 1? You know, it's 4 multiplied by 2. Area of 1. 4 multiplied by 4L multiplied by L. So it will be 4L squared. What is the area of 2? It's 3L multiplied by 2L. So it will be 6L squared. What is the area of 3? 4L multiplied by 2L. It will be 8L squared. And area of 4 is just 2L multiplied by 2L. So it will be 4L squared. So I know my answer now. Okay. I know each area and I know each x1, x2, x3, and x4. x1, I remind you, this is it. x2 is this, x3 is this, and x4 is this. And I do the same for the y. Y of the center of mass, of course, of my whole system will be m1, y1, plus M2 Y2. But of course, the M's will have rho H and the rho H will simplify. So I can just put the area directly. Area 1 Y1 plus area 2 Y2 plus area 3 Y3 plus area 4 Y4 divided by total area. Okay, I know each area. Area of 1 is known, area of 2 is known, area of 3 is known, area of 4 is known. I know Y1, I know Y2, I know Y3, and I know Y4. Okay, I just replace, and then I will get my answer. So at the end, you will get an answer of, let me erase this. Okay, so this is the X of the center of mass, and this is the Y of the center of mass. Here I did differently in this solution. I just consider 3 areas. This one here, and this one. But I prefer to consider 4 areas. Anyway, the solution will be the same. Let me share with you, because this I already solved it a long time ago in my recitation. Okay, so you see, I solved this in this recitation. You can go to my website, you will find this solution. Okay, this is exactly what I explained here. Okay. And of course, you will get the same answers. Okay, you can find this in my recitation problems. So please go to my website as well. You have a lot of resources. Okay, just enjoy. Okay, now let me go to the next problem. This is an A+ problem, okay? And in the lecture slides, there is a problem also I want you to solve with a uniform plate, and it's in the book. I talked about it in class. Now, next problem is about this. I have a stationary block lying on a frictionless floor, and the block explodes in 3 pieces that slide across the floor. Which of the following quantity will not be equal to 0 after explosion? So let's have a top view. Okay. This is my initial state. I have my block on my table. Of course, the block has a mass, capital M, and the velocity of the block initially is 0 because it's at rest. So the momentum of my block is mv initial is 0. Now the final state is after explosion. I'm still on my table. Now it explodes into 3 pieces. I have piece A of mass A, which has a certain velocity A, okay, VA, and I have piece B of mass B that has a certain velocity VB, and then I have piece C of a certain mass, which has a certain velocity VC, okay. So the question is, which of these following quantity will not be equal to 0 after explosion? So as I said in class, explosion and collision, I will always have conservation of momentum. Okay, because the explosion force and the collision force are internal force. So whenever I have explosion or collision, net force is equal to 0. Okay. Net force, I'm talking about sum of all external forces. The collision force and the explosion force are internal force. So net force is equal to 0. You know that Newton's second law is just derivative. Net force is derivative with respect to time of momentum. Net force is equal to 0 means momentum is constant. Mean I have conservation of linear momentum before is equal to linear momentum after. Okay. Linear momentum before explosion is equal to linear momentum after explosion. So linear momentum before explosion was 0. So that means linear momentum after explosion is 0. Okay. So this one is 0, of course. This is correct. This is 0. Now, what is the linear momentum after explosion? Of course, linear momentum after explosion is MA VA plus MB VB plus MC VC. Okay, and this should be equal to 0. So if this is 0, of course, that means if I divide by the total mass, this is just the velocity of the center of mass. Of course, the velocity of the center of mass is 0. Okay, a collision or explosion will not change the velocity of the center of mass. Okay, the velocity of center of mass will remain the same before and after. Okay, especially in here, because net force is equal to 0. Okay, the velocity of center of mass is 0. So if the velocity of center of mass is 0, of course, net force, as we said, is equal to 0. It's also equal to total mass multiplied by acceleration of center of mass. So that means acceleration of center of mass is equal to 0 as well. Velocity of center of mass is 0 means the center of mass does not change. So the displacement of center of mass is 0. So all this, I'm talking about the same thing. But of course, the total kinetic energy, it will not be equal to 0. So this is the correct answer. Okay, because the total kinetic energy before is 0. Okay, it's half mv initial square, but v initial is 0. But after, it will be kinetic energy of A plus kinetic energy of piece B plus kinetic energy of piece C, basically half mva square plus half mvb square plus half mvc square. Of course, m here is ma, here m is mb, and here is mc. And of course, ma plus mb plus mc is equal to total mass initial, because there is no loss in mass. Okay, so this is the correct answer here. The rest is equal to 0 because conservation of linear momentum before and after explosion. Okay, now let's look at this problem here. So I have object A of mass m moving along the x-axis with an initial speed of 5. It then collides with another object B of mass 4m, which is initially at rest. Okay. Let me just plot that. Initial, this is what I have. I have an object A of mass m moving in the x direction. Let's say it's moving this way. Okay. V A initial is equal to 5 plus 5 meters per second I hat. Why I'm saying I hat? Because it's moving along the positive x direction. And then I have here object B. So this is object A. Object B is here. And object B, VB initial is equal to 0. Because object B is initially at rest. And as I said, MB is equal to 4M. Okay. Now, after collision, this is before collision. After collision, what do I have? So let's say I will take this. This is my x-axis and this is my y-axis. After collision, A moves with a speed of 2.5 meters per second in the direction 60 degrees of its original direction. Okay, so after collision, let me take another color of my pen. I have A, which is moving in this direction. In this direction, this angle is 60 degrees, and A is here with mass M. And now VA final is equal to, in magnitude, 2.5 meters per second. Okay, good. Now, if the collision is inelastic, determine the direction of the travel of object B with respect to x. So object B, I know that this is what we call a glancing collision. Okay, this A is going in this direction. Of course, B will go in this direction. Okay, now B will go here in this direction, but the problem is I still know that B has a mass 4m. I don't know what is VB final. I can ask it, but here's the question is, what is this angle theta? What is this direction for B? Okay, so after collision, I have a glancing collision. After collision, A goes in this direction with this speed. B goes in this direction with a speed that I don't know, but I can know it, with an angle that I don't know, and I can know it. Okay, so how to solve this? It's a collision, elastic or inelastic collision. I always have conservation of linear momentum. So linear momentum initial, total linear momentum initial is equal to total linear momentum final. Okay? And now here is a glancing collision. So this is true along X, but also along Y. This means along X, of course, I have total linear momentum along X is equal to total linear momentum along X final. Okay. So total linear momentum along Y initial is total linear momentum along Y final. Okay. Now, what is the linear momentum initial here? Easy. P initial, let me write it down, okay? It will be MAVA initial plus MBVB initial, okay? Let me do it component by component. Of course, MA is M. VA initial along X is plus 5. And VA initial along Y is 0, because here VA has only one component along X. MB is equal to 4M. VB initial along X or Y are both 0. This is my PA. This is my total linear momentum initial. Okay, so along X, I will have 5M. And along Y, I will have 0. Okay. On the other hand, my P final, I will have what? MA VA final plus MB VB final. MA is M. Now VA final along X will be 2.5 cosine 60 degree. Okay. Along Y is the same, 2.5 sine 60 degree. Okay. I need this component along X and along Y. So along X is cosine 60 degree, along Y is sine 60 degree. Okay. Plus MB, now MB is 4M, 4 times M. And then here I will have VB. Now VB along X, of course it will be VB final cosine theta. And along Y, I know that it will be negative, okay? So it will be minus VB final sine theta. So P final, I will have two components. M multiplied by 2.5 multiplied by cosine 60 plus 4M VB final cosine theta. Along Y, I will have 2.5 M sine 60 degree and plus 4M VB final sine theta. Of course, here it's a minus, because here I have a minus, because this VB final is positive along X but negative along Y. So this is a minus. Okay. So if I come back to this, of course, that means this should be equal to 0. And this, this should be equal to 5M, and this should be equal to 0. Okay. So I will have two equations. The first equation is 5M, basically this is it, PIX is equal to 2.5 M cosine 60 plus 4M VB final cosine theta. And the second equation will be 0 is equal to 2.5 M sine 60 minus 4M VB final sine theta. And here I have my two equations, two unknowns. Okay, so I can get what is theta, and I can also get what is VB final. Okay, of course the M will simplify everywhere, and I have just two equations, two unknown. Okay, so the first unknown is VB final, and the second unknown is theta. Do you want me to solve it? Okay, let's solve it. So if I exploit this equation, I will just have what? For VB final, sine theta is equal to 2.5 sine 60 degree. If I exploit this equation, I will have what? I'll have for VB final, cosine theta is equal to 5 minus 2.5 cosine 60 degree. I will take the ratio. If I take the ratio, this 4 will go away, this VB final will go away. I will have just tangent theta is equal to 2.5 sine 60 degree divided by 5 minus 2.5 cosine 60 degree. So I take my calculator. That means theta should be equal to, how much did you get? 30 degree, right? Yes. So you do it, you calculate this, and then you take the theta. Of course, you will have theta of 30 degree. Okay, some good student talked to me before and asked me, they find theta is equal to minus 30 degree. I said, it makes sense because here, this theta is 30 degree below the x-axis. Okay, but me, I already took the minus into this, the component here. You see here? Okay. The minus, I did not put it inside the sign, you know, I put it already outside. And this theta, I take it as absolute value. Okay. I remove the sign and the minus is already here. If you don't put this minus, you will find the theta is equal to minus 30. And it makes sense because it's 30 degree below the x-axis. Now, once I get theta, easy. I have my first unknown. The second unknown will be VB final. So can you find what is VB final? And tell me, how much do you get? That can be a quiz in next, question in next quiz. Okay, so let's look at this problem here. We have a car and a truck initially at rest at a traffic light. Then they start accelerating in the same direction when the traffic light turns green. The acceleration of the car is given. So a car is constant is 15 meters per second square. And a truck is constant is 5 meters per second square. Now I said if the mass of the truck is 3 times, so m truck is 3 times mass car, then what is the magnitude of the velocity of the center of mass after 4 seconds? Okay, so here I have constant acceleration. So you know that if I have constant acceleration, well, I know that velocity of car at any time is the initial velocity of the car plus acceleration of the car multiplied by t. Both initial velocities are 0, okay, because they start from rest. So it's just 15t. And then the velocity of the truck is initial velocity of the truck plus acceleration of the truck t. So it will be 5t. And this is what, by the way, okay? These are just the velocities because the acceleration are constant, chapter 2. Now, what is the velocity of the center of mass 4 seconds later? You know, I said it in class, the velocity of center of mass is equal to what? Mass car, velocity of car, plus mass truck, velocity of truck, divided by total mass, mass car plus mass truck. Okay. So 4 seconds later, I have mass car, okay? M, let me call it M, multiplied by velocity of car, which is 15t, which is 15 multiplied by, because I'm looking 4 seconds later, okay, plus mass track is 3 times the mass of the car, I already said it here, multiply by 5t, and t is 4, divided by total mass is mass car plus mass track, which is 3 times mass car. And you see the mass goes away, okay, I will end up with 15 times 4 plus 15 times 4 divided by 4. And you see that this gives you 30 meters per second. And this is the velocity of the center of mass. Okay, 4 seconds later. So now another question can be, what is the position of the center of mass? Okay, of course, this you know it. So it will be M1 or M car X car plus M track X track divided by total mass, which is 4M. Now, what is X car? Of course, X car at any time will be 15 divided by 2t squared. And X track at any time will be 5 divided by 2t squared. Okay, because both of them start from the origin, plus 0, of course, plus 0. So it's just this, and you plug it here, and you will get what is the position of the center of mass at any time. Clear? Okay. Now let's go to this problem here, which is also a simple problem, but interesting. So I have a bullet, and the bullet has a mass 3.5 gram. Of course, you put it in kilogram. I will write M bullet is 3.5 10 to the power minus 3 kilogram. So it's fired horizontally at 2 blocks at rest. So I have block 1 and block 2. Both of them are at rest. So that means V1 initial is 0 and V2 initial is 0. Now, the bullet passes through block 1, and I give you the mass of block 1. Mass of block 1 is M1 is 1.2 kilogram. And I give you also mass of block 2 is M2 is 1.8 kilogram. Okay, this is M2 and this is M1. So the bullet passes through the block 1 and embeds itself in block 2. So the blocks end up with a speed of V1. So here V1 is given. V1 is equal to 0.63 meters per second. And V2, which is this block, is given, which is 1.4 meters per second. So neglecting the material which is removed from block 1 by the bullet, find the speed of the bullet as it leaves and enters block 1. Okay, good. So the thing is, okay, the first question is, find the velocity of the bullet here when it gets out of block 1 here. Okay, that's the first question. And the second question is, what is the initial speed of the bullet here? Okay, so here, let me call it VB2. What is VP2? The velocity of the bullet after it gets out of the first one. And what is the initial velocity of the bullet? Let me call it VB initial. Okay, these are the two questions. Easy. So in the first case and in the second case, both of them, in the second case, I have a completely inelastic collision because the bullet embeds in block 2. So I have conservation of momentum in block 2 after collision. So what do I have? I have momentum before is equal to momentum after. What is momentum before? Momentum before is mass of the bullet multiplied by the velocity of the bullet. But the velocity of the bullet, I'm looking at the velocity of the bullet 2, VB2, because it will get out from the first block with VB2 and it will enter this block with the same VB2. Okay. So it will be mass of the bullet multiplied by VB2. Okay, I project everything in the x-axis. Okay, and that's plus mass of block 2 multiplied by V2 initial, which is 0. Okay, and this is equal to what? This is equal to momentum after. Momentum after, since it's a completely inelastic collision, the bullet is embedded inside the block 2. So I will have total mass, basically mass of the bullet multiplied by, plus mass of block 2 multiplied by V2. Okay, so this will give me what? VB2. VB, velocity of the bullet 2, which is velocity of the bullet as it leaves the block 1 and enters the block 2. So it will be what? It will be V2 mass block plus mass bullet, okay, divided by mass bullet. Okay, and you do it, how much do you get? You will get, the first is, okay, this velocity here is 721 meters per second. Okay? Just by conservation of momentum between this bullet here and the block and bullet, basically a completely inelastic collision. That's why here they share the same final velocity. Okay. Now, once I get this VB2, now it's easy. I can get what is the VB initial of the bullet. Okay, what was it? How I will do, I will also use conservation of linear momentum. So linear momentum before is equal to linear momentum after. Linear momentum before will be mass of the bullet multiplied by VB initial that I don't know, plus mass of the block multiplied by the initial velocity of the block, which is 0. So this is 0. And this should be equal to what? Mass of the bullet multiplied by VB2 that I already found. So I know mass of the bullet, I know VB2. VB2 is the previous question. Plus mass of block 1 multiplied by V1. And V1 is here. Okay. So that means VB initial is just mass of bullet multiplied by VB2, which is 721 plus M1. M1, I know it. What was M1? 1.2 multiplied by V1. V1 is 0.63 divided by MB, which is 3.5, 10 to the power minus 3. And that will give you a VB initial of 937 meters per second. So here, the initial velocity will be 937 meters per second. It enters here and gets out with a VB2, which is 721, and it will enter here with the same velocity, 721 meters per second, and then it will be embedded here, and everything will move at this velocity V2, which is 1.4. Okay, good. Now here I said something very important. I neglected the material removed from the block. Actually, there is no change in mass. That's why I can talk about this in momentum. Okay, I consider that before and after, the material that is removed here is negligible compared to the mass of the whole block. Okay, so that's an approximation, and it's a strong approximation. So in reality, in the process, I lose masses. It's like when I have an explosion. When I have an explosion, I lose mass. But if I neglect the mass that I have lost, I will just say, oh, before explosion, I have this. After explosion, I still have 3 pieces, but the sum of the 3 masses will be still the total mass of the object before explosion. Okay, now let's look at this problem. Well, this problem is also very, not difficult, okay? But they combine different ideas. So let's look at it. I have this bullet here. It has a certain mass. M is 10 gram, basically 10 to the power minus 2 kilogram. Okay. This is the mass of the bullet. So it moves upward with this velocity here. So the V bullet initial is equal to 1,000 meters per second. And it passes through this center of mass here, of this object here in wood, so which was initially at rest. So capital M is 5 kilograms, the mass of the block, and VM initial is 0 because it was at rest. So now the bullet comes out here, so it passes through it and comes out with a velocity, let me call it VB final, and I said it's 400 meters per second. So the question is, what is the maximum height of the block when it jumps? Okay, because of course, because of conservation of momentum, this block here will be pushed up. Okay, it will rise above its initial position. So the question is, what is the maximum height it will rise? Okay, so it's a collision. It's a kind of collision. So I have conservation of momentum. Basically, momentum before should be equal to momentum after. Here I will project only on the y-axis. In the problem before, it was a one-dimensional, I just project everything along the x-axis. So here I will project everything along the y-axis. So initial, I will have mass of the bullet multiplied by VB initial. I know both of them. Plus mass of the block multiplied by velocity of the block initial, which is 0. Okay. Is equal to what? Mass of the bullet VB final plus mass of the block, velocity of the block final. Okay. So here I know everything. My only unknown is the velocity of the block final. So VM final of the block final will be just M bullet VB initial minus VB final divided by total mass. So I know the velocity of the block final. So it will be 10 to the power minus 2 multiplied by VB initial is 1,000 minus 400. So this will give you, of course, 600 divided by total mass, which is 5. Okay. So this will give me the velocity of my block final. And that velocity of the block final is going up. Of course, I will have my block here. It has a certain mass, 5 kilograms. Now it has a velocity VM final. Now the question is, what will be the maximum height? Okay, of course, it will go up at maximum height. Velocity of my block will be 0. Okay. So I will just have a conservative system. So I will have delta K plus delta UG is equal to 0. Okay. Final minus initial, so K final is 0, K initial is half M VM final square. This is equal to delta UG. Okay. So let me put it this way, plus MGH, and this is 0. Of course, it will be independent of M. So H is just equal to what? Basically, VM final square divided by 2G. So you do the calculation, you will find, of course, this number, 0.073 meters. And this V here is 1.2, okay? Because you can see it here. If I have 600, of course, multiplied by this, I will have 6 divided by 5. Okay, 6 divided by 5 is 1.2. So VM final is 1.2. Now the question is, with 1.2 meters, how far will I jump? Okay, you will jump by, this object will jump by 0.073 meters. Just by conservation of mechanical energy, chapter 8. Okay, the whole kinetic energy here, half mv final square, will be transformed into mgh, and that's what I get here. Okay, so that's very, let's say, straightforward. And this is what I explained here. Okay, it's very clear. Okay, now let's go to this problem here. So I have a particle of mass m1, 1 kilogram, moving towards the east, moving in the positive x direction with a speed of 2 meters per second. Okay. Then it makes a head-on collision with a particle m2 of mass 5 kilogram, moving towards the west. So it's a head-on collision. It's a one-dimensional collision. Now the particle m2 has a speed of 4 meters per second. Calculate the velocity just after collision. Okay. So here I said a head-on elastic collision. Well, you know, in a head-on elastic collision, I have conservation of linear momentum, but also I have conservation of kinetic energy. Okay. So you remember this, we solve it in class. Okay. So I don't want to write it again. You go to class, you will see it. But at the end, I showed you that you will have a system of two equations. You can write the final velocity for particle 1, if you remember correctly, is equal to what? The formula sheet. Okay. It will be m1 minus m2 divided by total mass, which is m1 plus m2, multiplied by v1 initial plus 2m2 divided by total mass multiplied by v2 initial. Okay, and v2 final is equal to what? 2m1 divided by total mass, and this is in your formula sheet, right? v1 initial plus m2 minus m1 divided by total mass, v2 initial. Okay, and this is true for a head-on elastic collision. Elastic, this is a key word here. Okay. Elastic collision, I have not only conservation of linear momentum, but also conservation of kinetic energy. And if I solve this system of equation, as I showed you in class, I will end up with these formulas. Head-on elastic collision. Now, let's go for it. I know the masses, m1 minus m2, I know. m1 plus m2, I know. v1 initial are moving towards the east, so it's plus 2 meters per second. But v2 initial is moving toward the west, so it will be minus 4 meters per second. So be careful here. This gentleman here, v2 initial, is minus 4 meters per second. This v1 initial is plus 2 meters per second, because these velocities can be positive or negative. Okay, it's a projection of the velocity along the x-axis. Okay, so it can be positive or negative. They are not magnitude. They give you direction as well. So that's it. If I do that, I get my answer. So this is in the formula sheet. This is the final velocity for particle 1, and this is the final velocity for particle 2. You do the calculation. Be careful. This is plus 2, but this one is minus 4, because it's moving toward the west. Okay, it's moving in the negative direction, as you can see. So it's minus 4. This is plus 2. Okay, I do the same. This is minus 4, as you can see, and this is plus 2. And I just apply the formulas, and I see. Okay. So when I calculate, I find for the first particle minus 8 meters per second. That's the final velocity for the first particle. And for the second particle, minus 2 meters per second. Okay. So after collision, you see that both of them are moving in the negative. So M1 here, after collision, this is initial. Now final, M1 will move in the negative direction. That's why I have here minus. It will move in the negative direction, and it will be minus 8 meters per second. And this big mass will move also in the negative direction, and it will have a velocity of minus 2 meters per second. Okay, and you see the new distribution of velocities. Okay, and this is coming from conservation of mechanical linear momentum, but also conservation of kinetic energy because it's a elastic collision. Now I will tell you something here. You can notice it. You will see that always when I have a head-on elastic collision, you will always see that V1 initial plus V1 final is equal to V2 initial plus V2 final. This is just a way to check your answers, and this is true for a head-on elastic collision. Look at V1 initial. V1 initial is plus 2. V1 final is minus 8. So you see it's equal to minus 6. What about V2 initial? V2 initial is minus 4, and V2 final is minus 2. And you see it's equal to minus 6. And this is a good way to check if I got it right in an elastic collision, head-on elastic collision. Okay. This is just for your information. It's a good way to check if you have an elastic collision. But what you need to remember is this formula, of course, and this formula, of course. Okay. And know that these can be positive or negative. Okay. Okay. Good. Because they are projection of vectors on the axis. If I move in the positive direction, it's positive. If I move in the negative direction, it's negative. That's why after collision here, both particles will move towards the negative direction, toward the left, toward the west. Okay, so should I solve this problem here? Let me skip it. Straightforward. Please write it down and solve it. It's a good problem, by the way. Okay, it's an A problem. So please solve it. The answer, of course, is this. Okay. So have a look at it and solve it. Let me go to this problem here. So the figure here shows F versus T. I give you the force versus time during a collision. So I give you how the collision force is varying in time during a collision between a particle of mass m, and I give you the mass of the particle is 7 T 10 to the power minus 3 kilogram. Okay, and this is a particle of, this is the mass of my particle. Okay, so I give you this. Basically, I have a vertical wall, and I give you the initial speed of the ball, and then the ball rebound, and then I give you the final speed of the ball against the wall. So let's say this is a wall. Okay, the wall has an infinite mass compared to the ball, of course, right? So the wall will not really move. But the ball was coming with an initial velocity of plus 40. And then it bounced against the wall and it goes back. Now, when the ball is going back, he will go perpendicular to the wall again, and the final velocity for the ball. So here I say plus because, of course, my positive x-axis is going this way. Now, when I bounce back, V final will be equal to what? Minus 30. Okay, because it's 30, but in the negative x direction. So the question is, what is the value of F max? So here I have an impulse. I have a collision between the ball and the wall. Okay. So I know that impulse, which is the change in momentum of the ball, is just m multiplied by V final minus V initial. This is the impulse on the ball. Okay. So it will be mass of the ball multiplied by V final of the ball minus V initial of the ball. Let me put numbers. Here it will be 7 10 to the power minus 2 kilogram. Now V final, what is V final of the wall? Of the ball is minus 30. Minus V initial, minus 40. Okay. And this is it. Okay. Now here it's negative. Why? Because the ball will feel a force which is in the negative direction. Okay. So the ball will bounce against the wall, right? So the ball will feel a net force which is negative, but the wall will feel a net force which is positive because they are third lope. Force on the wall by the ball is equal and opposite in magnitude to the force on the ball by the wall. So that means impulse on the ball, okay, is equal in magnitude but opposite in direction to the impulse on the wall. Okay. Of course, in magnitude, they are the same, absolute value. So here, this minus, don't forget it. So it will be 7, 10 to the power minus 2. Why minus 2? Okay, minus 2 multiplied by minus 70. Now this delta P will be equal to what? I said it in class. The impulse is also equal to the integral between T initial and T final of the collision of F dt. And here's the force is varying, okay? So F dt, I gave you F here and I gave you the time. So I need the area under the curve. So you calculate this area under the curve. Of course, you have this triangle, and of course you have this rectangle. So you can calculate it easily, okay? And be careful here because this time is in millisecond. I have to put it in seconds. Is it clear? Okay, let me just solve it here simply. So this is what we did. Okay, this is what we did. This is the impulse, change in momentum for the ball. Mass of the ball, V final minus V initial. Okay, I project along X. This is what I have. Okay, I already talked about this part. Now the area under the curve will be equal to this. Okay, this 10 to the power minus 3 is because 1 millisecond is equal to 10 to the power minus 3 seconds. When I calculate the area here, of course, you know, this basis is a half. So let's calculate the area if you want. This area is equal to this area here. Okay. So basically I will have 2 times half. The basis is 2, but 2 milliseconds. So I have to multiply by 10 to the power minus 3, multiply by the height. The height is F max. Okay. And then I add the area of this triangle here, of this rectangle here. So plus 2, of course, 10 to the power minus 3. Okay, so I have 2. This is 2 here. Okay, but I have to take, of course, 10 to the power minus 3 because it's in millisecond. I have to put it in second. Multiply by the width or the length, which is F max. So when you do it, of course, you have 4 times 10 to the power minus 3 F max. And this is equal to this, and this is the magnitude of the force. Okay, the magnitude of F max, basically the maximum force. Okay. So as I said, let me look at it. So as I said here, this problem will come again and again. There is another problem which exactly looks like this, but I changed it a little bit. Yes, you can look at this. This I gave it as a quiz last year. Okay? So be very careful here. Okay, here I said, what is the impulse on the cart after collision with the wall? I want the impulse on the cart. So this is positive X. The impulse on the cart will be positive. So this is the formula and it will be positive. But the impulse on the wall will be negative. Okay. So this minus 30 here is the impulse on the wall. Okay. Because the wall will feel a force which is negative. The cart will feel, because of the collision, a force which is positive. Okay. So this I gave it to my students and they made a mistake last year. And they were good students, by the way. But mistake happens. Okay. And be careful. Okay. The impulse, of course, if I use this m dv, this are the units, but these units are the same as Newton second, Newton multiplied by second. Okay, because you remember that a Newton is just a kilogram multiplied by what? Acceleration, meter second square. And then I multiply by a second, so I get the same thing here. Yeah, that's why this impulse is just F average delta t. Okay. Okay. You have other very important problems, okay? All of them are very interesting. I don't want to solve them all, So I want you to solve all of them, okay? This is a very interesting problem. It comes many, many times in exams, okay? This is a very interesting problem. A little bit difficult, but I gave you the solution. I want you to think about this. It's very beautiful, and the solution is given. You just do it step by step, okay? Now we did many different things. You put them together step by step. Okay? Of course, this is not an exam problem. I will not give you this in the exam. But for those who wants to go further, this is a very good problem. Okay, this is also a very beautiful problem. Okay, so you look at it, you can solve it easily. This is a conceptual question. This is a typical exam problem. It's the same bouncing, you know. So of course, the solution is this. But be careful here, what I said, the impulse from the ball on the floor. Okay? So basically, I'm looking at the impulse on the floor. The floor will feel a force which is negative, but the ball will feel a force which is positive. Okay, so this is the right answer. Okay, not this one. This is an impulse on the ball. This positive one is an impulse on the floor. Anyway, this is also very beautiful, and we solved this in class, if you remember. This is a very beautiful problem, but difficult. It's for A+ student. Okay, so please solve it. You know, just solve as much as you can, but most importantly, understand what you are solving. Okay? Understand what you are solving. Okay? This problem, you know, this problem comes many times. I want you to solve all of them. Okay, now let me move. So this problem is important because it's like an explosion, but I am taking a spring as a model for explosion. So have a look at it. It's really beautiful, especially this part. Okay. So this is easy, but this part, you have to know that I have conservation of mechanical energy, because here, this is just a kind of model for explosion. Model for explosion. Okay. And then in an explosion, of course, you have net force is equal to 0. That means you have conservation of mechanical, conservation of momentum before and after explosion. Okay. Okay, I give you as a problem, so you know, please help yourself, solve as much as you can. Okay, I want to come to here. Yes. Okay, this problem, the masses are the same, so they are just swapping the velocities. Okay, and I talked about that in class. When the masses are the same, conservation of well, I can write it down. Okay, this is V1 final. By the way, it's an elastic collision. Okay, perfectly elastic. Okay. So that means V1 final will be what? M1 minus M2 divided by total mass multiplied by V1 initial plus, okay, so here I will have 2M2 divided by total mass multiplied by V2 initial. And V2 final will be 2M1 divided by total mass V1 initial plus M2 minus M1 divided by total mass multiplied by V2 initial. When M1 is equal to M2, like in this billiard balls, what will happen is they will just swap the velocities. Okay? The velocity will be swapped. So M1 is equal to M2, this is 0, and of course this is 0. And 2M1 plus divided by total mass, this is equal to 1. And this will be equal to 1. So that means V1 final will be just what? V2 initial. And V2 final will be just V1 initial. So the first particle will take the velocity of the second particle, and the second particle will take the velocity of the first particle. And that's why here you have minus and plus 30, minus 20 plus 30. At the beginning, what did I have? I had plus 30 and minus 20. Okay, so they are just swapping the velocities because they are the same mass. Okay, so here you can use it with a car. Okay, and it's really beautiful to use these things for the car. Okay, please solve it. Okay, here I have a completely inelastic collision, so they stick together. Completely inelastic collision, so they become entangled. Okay, I cannot solve all of them, but solve it. You look at the kinetic energy. Of course, it will not be conserved. So I will have a loss in kinetic energy. And that loss is what you see in the damage. Okay, because here you will have damage. So the kinetic energy will not be conserved, of course. And you can calculate what's the change in kinetic energy, initial and final. And you take the difference and you will see that it's not equal to 0. So this is a loss in kinetic energy. When they are entangled, you have the maximum loss, of course. And here I give you a car crash test. Please look at it, okay? Look at it and solve it, okay? I don't, it's, yeah. So you can see it here, these nice remarks. Okay, just have a look at it. It's beautiful. Okay, I want you to solve all of them. So let me stop here. Okay, you have many problems. Please solve them. Before I finish, let me just talk about some problems I gave my students in previous semesters. Okay, so look at this. It's in my website, okay? This is a typical problem. Let's read it. So we have a body of mass 2 kilograms. It makes an elastic collision. So you know that I have these formulas. I have conservation of conservation of linear momentum, but also conservation of kinetic energy. And they will give you these two formulas. Okay. So I know the mass of the first body, and it collides with another body at rest. Okay. And it continue to move in the same original direction, but with 1/4 of its original speed. The question is, what is the mass of the other body? M1 is equal to 2 kilograms, M2, I don't know. I know V1 initial. I did not give it, but I just said that the V1 final is equal to 1/4 of V1 initial. Well, I know V2 initial is 0. V2 final, I can get it later. Okay. Good. Now I use these formulas. I know that here V2 initial is 0, V2 initial is 0. So both of these is 0. And then I will use the first one. I will say just V1 final is M1 minus M2 divided by total mass M1 plus M2 multiplied by V1 initial. And I said that V1 final is 1/4 of V1 initial. And then I have this. So I have an equation. The only unknown will be M2. And you do it, it will be 6 divided by 5. It's 1.2 kilograms. Okay. Now, second question. I said if the initial speed of the body was 4 meters per second, what is the final speed of the other body? Easy. You do it. Okay. You get it. You use the second formula. Okay. Now here this is 4 meters per second. You just apply your formula. Okay. And what is the final speed of the first body as well? You can get it. And since it's an elastic collision, I told you, you can check. As I told you, you can check that V1 initial plus V1 final is always equal to V2 initial plus V2 final. Don't use this to solve a problem. What do you use to solve a problem is these formulas, okay, in an elastic collision. This is true for an elastic head-on collision, elastic one-dimensional collision, okay? But this, you use it to check, not to solve. To solve, you use this, okay? Now, let's check. V1 initial, what was V1 initial? V1 initial, I believe, was 4, right? V1 final is 1. So you see, 4 plus 1 is equal to 5. What is V2 initial? V2 initial was 0, V2 final is 5, you see? And you see that it matches. But to calculate, you use these formulas, right? These formulas here. But this is just to check in a one-dimensional elastic collision. Good. Now, finally, let's go to the last question, which is even more important. Find the velocity of the two-body center of mass. Does it change before and after collision? As we said in class, the center of mass, the velocity of the center of mass does not change because of collision. Okay? And this is coming from conservation of linear momentum, which is coming from net force is equal to 0. Okay? Collision does not change the velocity of center of mass. So let me calculate the velocity of center of mass before and the velocity of center of mass after. Okay? Velocity of center of mass, it will be m1 v1 initial plus m2 v2 initial divided by total mass. I calculated, it gives me this. I can calculate the velocity of center of mass after. This is the velocity of center of mass before. After, it will be m1 v1 final plus m2 v2 final divided by total mass. It will give me the same velocity of center of mass. And this, I know it already. Okay, because net force is equal to 0. That means ma is equal to 0. That means a is equal to 0. A center of mass is equal to 0. That means velocity of center of mass is constant. And this is coming from basically the conservation of linear momentum. When net force is equal to 0, linear momentum is constant before and after. And this is another way to say that the velocity of center of mass is not changing. Okay, so thank you very much. We have a quiz on this chapter, inshallah, next Thursday. So wish you the best. Assalamu alaikum.